Okay, hi guys, my name is Martin Herkommer, Sales Manager at Quantum Systems Germany. Today I welcome you here on the rooftop test flight area of Quantum Systems at our headquarters in Gilching. Today I would like to show you how to fly the Trinity, how to do the mission planning, how to assemble the Trinity, and we will go step by step through the procedures. So all we need is in this easy to transport box, and this is the main body of the Trinity, and here below the main body we see the payload compartment. I will just show you. Today we will fly a Sony RX1 camera with 42 megapixels, and I will assemble the aircraft right in front of the box, and I hope you don't mind that I will wear my sunglasses because today is a super bright and sunny day, and this is much better for me. So these are the wings. The wings are locked to the system with a fast locking mechanism with a single button to lock and unlock the wings, and they just easily flip in, and they are locked once you hear the sound. It's important to listen to the click sound of these wings, and that easy. Next, we remove this little inlay with the battery, with the flight battery, and below the flight battery there is the rear fuselage, and the rear fuselage is plugged into the main body of the Trinity, to the main fuselage, and it just clicks in with the same sound. And finally what we need, of course, is the elevator, and this elevator flips into the right position by just pushing it down. So technically that's it. We can use some additional strobe lights, anti-collision lights, and we will put the green one on the right side and the white one in the center and the red one on the left side. So now we are pretty right to go. What else do we need? We have an air modem. This is a kind of transponder ADB-B receiver, which I will plug into my laptop to be able to monitor the entire air traffic around this airfield here. So we see all the manned aircraft and the drones in the air. What else do we need? We need the telemetry modem. This is a micro-hard modem with minimum 8 kilometer range, and I will also plug this modem into the laptop, and we will use the modem to upload the flight plan to the Trinity and to control the Trinity in the air and to visualize the Trinity on the moving map. So next I will place the Trinity on the takeoff location over there with the nose facing into the wind, or more or less into the wind. And finally we will plug in the battery, and this will already power the Trinity, and then the system is ready to go. And we will plan a mission, upload the mission, and then I will show you how to fly this mission. So now we will look at our 3D planning software Cubase, and I will now show you how to plan a mission and how we will upload this to the Trinity. Okay, so this is Cubase 3D, our flight planning and mission monitoring software, and now we will start creating a new mission. So new mission, and here we can already see the location of the aircraft on the rooftop. And first of all we go to the mission settings, where we can select the right aircraft and the right camera. So of course we want to use the RX1 camera, 42 megapixel. We can set up the speed of the aircraft between 17 and 20 meters per second, and a link loss tolerance, which means after 30 seconds, if we select 30 seconds, the aircraft will come home if we would have a link loss. Okay, that's all good. Next, we create a new element, and we can draw either an area or a corridor for corridor mapping, or we can load files, KML files, to do automatic mission planning. So I would like to draw an area, and this area I would like to draw somewhere here, right in front of our building. So this is an area covering 11 hectares in 100 meter. We can change the altitude higher or lower, or we could change the side overlap here, or the forward overlap, or even go to advanced settings, changing the leg direction, left or right, or we just keep it like it is. So we finished this element, and now we can see we have 21 waypoints, and we just need a takeoff location, and the takeoff location is here where the aircraft is, and this takeoff location we can slightly adjust and bring it into the right direction so that the takeoff is going to the southeast. And I will close the opening cone a little bit so that the aircraft will definitely not fly over the neighbors' buildings. So this is all we need to do for the takeoff. Takeoff transition altitude is 20 meters. That means it will vertically climb to 20 meters and then accelerate to a fixed wing mode. I'd like to bring this down to 10 meters. And finally, we have to adjust the retransition point. That's the point where the aircraft stops and approaches for the landing. I will place this a little bit ahead of the landing site, and we can choose the approach angle towards the wind direction, and we can select whether it's a right-hand traffic circuit or a left-hand one. So this looks pretty good, and approaching altitude for the horizontal flight is 30 meters. So all fine. We are now good to go, and what we finally do is we click on monitoring, and once we are in the monitoring mode we can upload the mission to the aircraft. Some low altitudes are detected. That's for the departure, because the aircraft is not knowing that we are taking off from the building right now, but we checked for obstacles in all directions, and we confirm the flight plan, and we write the flight plan to the Trinity F90 Plus.
Mission successfully uploaded.
So we hear the voice, mission successfully uploaded. Okay, before we fly, I would like to show you the iBase, which is a PPK base station included to the system bundle. This is the antenna. This is the iBase receiver for logging Rhinex data, which we'll later use for the post-processing. And I will put this base station on a known point. The corner of this edge here, and we just plug in the little USB cable to the iBase, and then it will start logging. And I check the color. It's blinking blue. That means it's logging the data. Okay, let's now walk to the aircraft. So now the aircraft is ready for takeoff. I will activate the anti-collision lights. So, and from now on, we do not need to be close to the aircraft. This is a real advantage of the Trinity F90 Plus, that the pilot stays in a safe distance to the aircraft. We just need the remote control or the laptop. We press pre-flight check, and then I can immediately see that the pitot tube is working. I see the wind speed. So the speed measurement is okay, and I will now check the control surfaces like the ailerons left and right, and the elevator up and down. And now we are prepared for takeoff. I will now press arm, and yes, the motors will start spinning. All the motors are now in a vertical position. Now we press takeoff, yes, and then the aircraft will automatically climb and do the transition towards the mission. Climbing to 100 meters, and we can now watch the mission on the laptop. So we can see the aircraft climbing, and the aircraft is now proceeding to the first waypoint. On the upper right corner, we see an altitude profile diagram showing the altitude of the aircraft above the ground, wherever the aircraft is at this moment. Now the aircraft will perform a left turn heading towards the first leg, and once established on the first leg, it starts triggering images. There's a wind indicator at the left wing of the aircraft, this green triangle showing the wind speed 2 meters per second and the ground speed of the aircraft 17.2 meters per second. So now performing left turn. So while we monitor the Trinity's flight path on the laptop, we can watch the aircraft, and here we can nicely see the silhouette of the Trinity flying in this direction. And so it's important to monitor the airspace a little bit, especially here being on this airfield, but we also have plugged in our aircraft traffic receiver, but there's no aircraft traffic around us for the moment, which is fine so far. So now the aircraft did turn again, flying now from right to left, 100 meters above ground, and shooting the images with a 70% overlap in flight direction. Yeah, for the moment we have 61, now 63 images. In the upper middle part of the screen you can see a camera symbol, the green camera symbol counting the images. And once we click on this camera symbol, we get even more details. We can see if we would have missed an image. So we get camera feedback, and now we can clearly see 76 of 76 images. So there are no images lost on this flight, and that's what we are used to. We can of course monitor much more. We can monitor the aircraft's health data. We can see the ESC temperatures. We can monitor the battery, and there are many other available parameters we can monitor during the flight. And of course we should not forget to monitor the airspace, to see the aircraft while it's in the air. That's the main duty of the remote controlled pilot, to watch the aircraft and to make sure there are no other vehicles nearby. By the way, we are flying here in the controlled airspace of Oberpfaffenhofen. We got the clearance from the controller on the tower, so he knows that we are operating an aircraft right now inside his airspace, and he would tell us by radio if there is any alarm, any traffic we have to avoid. Okay, now the Trinity is on its last leg. We can see here on the moving map, but we can also see here in the air, the Trinity is flying the last leg. Then it will fly into the descent circle at 100 meter altitude, and it will spiral down. It will descend into the descent circle down to 30 meter above the landing site. Then it will fly towards the landing site, it will stop, it makes a full stop in the air and hover down to the ground, and I will always be in a safe distance from the aircraft I watch the aircraft and I'm here with the remote control just for minor modifications if we would miss the landing site due to some GPS tolerances. So now the aircraft is flying into the descent circle, and now we can clearly see the aircraft is circling clockwise and it's losing some altitude. Now we are at 78 meters altitude and we will roughly lose about 10 meters per round. Now we're at 70 meters above takeoff. And as I mentioned before, earlier, the aircraft will stop the descent at 30 meters above takeoff. Now we are 66 meters above takeoff. Another round, 50 meters above takeoff. And now we are approaching, and now you can see the transition. The aircraft is stopping in the air. I'm actually doing nothing. I just watch the aircraft descending while it's flying towards the landing location. I'm still not interacting. Now I stop it a little bit. And now we are landing and the motors will switch off. And that's pretty all. After about 30 seconds after landing, we can walk towards the system and we remove the battery, which will unpower the system. And then it's safe to grab the system and bring it to a place where we can start disassembling the Trinity. And later, indoor, I will show you how to process the data, how to take the data out of the system, how to transfer the images, how to transfer the fly log, and how we are going to use the rover data, the Rhinex files, for the PPK processing. Okay, now we put the used battery back to the box, and I will show you how to disassemble the Trinity, and you will see this is as fast as assembling the Trinity. We just unlock the wings and we put the wings back into the box. Next, I will unlock the elevator, and this elevator goes here in the lower part of this box. Thereafter, I will unplug the rear fuselage, and this rear fuselage will go above the elevator. So we put it carefully in with the propeller above the elevator. Next, we can put the battery inside this box, and finally we put the main fuselage into the box. And last not least, we are done. See you later. Hello again. Right now we are back in the office and I will show you how to post-process the data from yesterday's rooftop flight with the Trinity F90 Plus. For the next step, you will need a laptop and our Cubase 3D software. First, we run the Cubase 3D software and then we will transfer the fly log from the Trinity F90 Plus to the laptop. Therefore, we will plug in the included magnetic USB cable into the Trinity and we start a data transfer in Cubase 3D. So now we are in Cubase, we go to Tools, we click on SD card, so to access the SD card of the aircraft. And here we see under logs all the flylog files, and we go to the latest one and we just copy the latest flylog file and paste it into our project folder. So here's our project folder, and we just put this file in the folder flylog, and this should be copied right quickly. Once the data is transferred, we can unplug the Trinity and remove the USB cable. Then we remove the microSD card from the iBase, and we will use this little USB adapter to transfer the iBase GPS data to the laptop. Okay, here we can see all the iBase files, and the latest one is the one we recorded today. We copied the latest iBase file, which is a kind of a Rhinex file, and we copied this file and we put it in the project folder. So now we have the flylog and the iBase file. Last but not least, we will transfer the aerial images from the camera to the laptop. The high-resolution images are stored on this SD card inside the camera, and we will again use this little USB adapter to transfer the data to the laptop. So here we see the folders on the SD card. We copy all the images and we copy them to our project folder on the C drive. So all the images are copied to the project folder. And now we will delete the first images which are taken on the ground. So these 8 images are going to be deleted. Okay, let's jump into data processing. So now we are using Cubase to geotag the images. We click on geotagging, and first of all we load the flylog file, the one we downloaded from the Trinity. So we load a fly file, and we will see there are 309 images, and there are precise positioning data available for this flylog, and we select the image folder. So all the images are here under images. We load them, same number of images because we deleted the ground images, so that fits very well. And the next step is precise positioning of the flylog. So the flylog file is analyzed, and then once this is done, we load the Rhinex file. We add the file, we go to the right folder, we open the iBase file, and the position will be detected automatically in this case, and the output is ellipsoid, and then we will start the precise positioning. So well, now the data is analyzed, the PPK is running, and at the end we will see a summary of the quality. And well, let's see, the quality is 100% fixed and 0% float. This is a perfect quality, and next step is to geotag the images. Therefore, we click on the geotag button in the lower bottom. We can press geotag, and now all the images are written in a copy, including the metadata of the latitude, longitude and elevation. That's it. So now we are ready to start the processing of the data with Argisoft. So now we are in Argisoft Metashape, and here we can see the final results. This is the dense point cloud, and we can zoom in to see the details. So this is a pretty nice colorized point cloud, and we even grabbed some points below the forest, and we can classify the points to ground points and non-ground points, which makes it later easy to calculate a surface model and a terrain model. This is the surface model, the 3D surface model. We can well see all the details on the roads and in the fields. And of course we can have a look at the order mosaic. Final results with Argisoft Metashape. And this is just one example for third-party software to process the Trinity F90 Plus data. For more information, please visit our website.